Hello Algebra, this is DeGrow here again. This is target 1.6 day 2. So we're finishing up all of our rules of exponents used to simplify expressions. This is on let's see here real quick, page we on? 22 in our packets if you're following along. And it starts with some overview of what we did before. So let's just recap our rules that we talked about yesterday. And the first one is if you multiply, you add the exponents. And if you take an exponent to an exponent, you multiply them. I'm not going to go over why that is what it is right now. You should watch the first video if you haven't to get that. And today we're going to talk about the quotient rule, negative exponents, and what happens when you have a zero power. Alright, so our third example real quick, just in recap, is you can distribute these exponents across. Now, one thing you probably should want to do before you do anything else is reduce this 3 and 6, but we'll pretend like I don't notice that. So you get 9x to the second, y to the negative 8th, because we're just multiplying it. Actually, sorry, let's back up. You should do, let's leave it the way I had it. Y to the negative 8th, y to the 14th, x squared over 36a squared. Negative 6 times negative 6 would be a positive 36. Okay, now I said we should have simplified what's inside. But if we're just blindly following what we did yesterday, we would just distribute everything. Now, we got some stuff inside we can do. Now, we could either divide 3 and 6 to begin with and get a half, or I can now divide 9 and 36 and get 1/4. As 9 goes into 9, 1 time, 9 goes into 36, 4 times. So we get 1/4. Alright, and then we just go across. X squared would make x to the 4th because we're adding. And a negative 8 and a 14 would make a positive 6. Now, let's back up real quick and say what would happen if we did simplify all this guy first. Or would we do something differently? No, let's take a look. So inside, we have 3 over 6. That should be a negative 1/2. I'm going to keep the negative with the 6, just because that's the way it was shown to begin with. So 3 goes into 3 once, 3 goes into 6 twice, so we have our 1/2. If x and x, that makes x squared. We have y to the negative 4th and y to the 7th. If I add exponents, I'm going to get y to the 3rd. But I still have to square this. And take a look over there. Do we get anything different? 1 squared is 1, negative 2 squared would be the 4, x squared would be x to the 4th, y to the 3rd squared would be y to the 6th. The second version of the problem is a little bit better than the first one because everything's just a little cleaner. There's less stuff on the page, but either way you go about it, you still have to get the same answer. Alright, so let's see what happens when you divide. Okay, we're going to do this very similar to what we did in the last one. We're going to expand it and see what happens. We have 3x's on top and 2x's on the bottom. And if you group them like this, you can really see it well. We got 2x's here and 2x's there. We can cancel them out in the same way that 4 divided by 4 is 1. So this is 1x or just x. We have 5 up top and we have 3 in the bottom. If I group these together, I can see that these 3 are going to cancel, and I'm left with x squared. We do the same thing with the next one. I think that's 8. 1, 2, 3, 4, 5, 6, 7. Oh, one more. And we put 3 on the bottom. And we're going to cancel out these 3, leaving ourselves with 1, 2, 3, 4, 5. Alright, so what do we notice about this condensed form? So what happened to all these up top? We had 8 of them and we took out these 3 here. So when you take something out, that's subtraction. Now one thing I want you to notice is when you had x to the 8th times x to the 3rd, we got x to the 11th. Multiplication, that was addition. Subtraction, division. So very, very similar as far as the order of operations go. And it is because you're dividing them out. And when you're cutting things out, you're subtracting. So nobody's going to write 150 of these and 20 on the bottom and then cut out 20. They're just going to cut out 20, and we're going to have x to the 130 without any more thought. Alright, so what's our rule? So it's x to the m divided by x to the n, and so we're going to get x to the m minus n. Now you notice I'm doing this top minus bottom. If you did it on the bottom, you can also write this as 1 over x to the n minus m. So whichever direction you subtract from, if you subtract top bottom, you stay on the top. If you subtract bottom top, you go on the bottom. Nobody does the second version. That's not something we're going to do. But people always ask me, like, well, why do you always subtract top minus bottom? And it matters, and we'll talk a little bit about it once we start talking about the negative exponents as well. But we haven't gotten there yet. So, do a couple examples. I'm going to do the tougher examples. I'll leave you the first couple ones. So 3. Don't forget, 14 divided by 2 is 7. It is not 12. However, when you talk about the y's, you have 15 y's on the top, 7 y's on the bottom. We're taking 7 out of those 15 because we're going to cancel them all out. And we're left with 8. So 15 minus 7 is 8. On the next one, don't forget, just because everything's up top so far, 4 goes into 4 once, 4 goes into 8 twice. You get a half. Now, you may or may not need a big fraction bar, but it doesn't hurt to put it there. Now, I know the a's are kind of across from each other. It doesn't matter. It's still top minus bottom. 18 minus 13, that would be a to the 5th. And then b's, 7 minus 3, that would be b to the 4th. And then what happens with these c's? Is it going to be c to the 0? Is it blank? Well, think about it this way. cc over cc. We cross them out. You can put a 1 there if you want, but we are good. They cancel out entirely. Now, this one's just like the warm-up one that I did before. I'm going to tell you guys, let's simplify these down first before we just start distributing the 3 in there. So 2 doesn't do anything if there's no other numbers. You have 4 a's on the top, 1 a on the bottom. 4 minus 1 is 3. For our b's, we got 5 and 3. 5 minus 3 is 2. And then we have to raise this to our third power. Distribute them all out. 6, a to the 9th, b to the 6th. And we are wrong. What was wrong? Right? We multiply, our exponents are good, right? 3 times 3 is 9, 2 times 3 is 6. Sounds good. 2 to the third power is not 6. 2 to the third is, again, we did this one earlier. It's 2 times 2 times 2, which is 8. Do not confuse rules of exponents with rules of numbers, okay? Biggest mistake students make it all the time, and you can decide for yourself whether that was a real slip on my part or just a joke. We'll see. Okay, let's see what happens next. Alright, negative exponents. So, the most basic thing you can do is expand them out and see what happens. We got 4, and we got 5, right? Now we cancel 4 with this 4, right? And you're left with 1x, but this is 1x on the bottom. So it's 1 over x. So there are more x's on the bottom, so it's 8 on the bottom, right? Alright, what happens with the quotient rule? It's x to the 4 minus 5 would be negative 1. But these two things can't really be in conflict with each other. These have to be the same, which basically means that x to the negative 1 is 1 over x. Let's try this again here. Let's see what happens. So 3 doesn't get expanded. It's just chilling there. We got 6x on the bottom. And I kind of lined them up in a goofy way, sorry. But these two will cancel. And we're left with 1, 2, 3, 4 on the bottom. So it'll be 3x to the 4th on the bottom. Now let's see what happens the other way. 3, 2 minus 6 would be negative 4. These two are the same, but we want this version. So what does that mean with negative exponent? It means it flips. This becomes 1 over x to the positive m. You notice how over here, this was not a negative 4. So if it was x to the negative 4 up top, it goes to the bottom and becomes a positive 4. And this works in either direction. If you have an x to the, so 1 over x to the negative 2, I can flip that up to the top and make that x squared. this goes in either direction. So either way you go about it, one of our rules is we're not going to leave any negative exponents. So you might say, well, they're equivalent to each other, but the rule is going to be, at least in my class, you can't leave it as a negative exponent. And there's for a couple different reasons. And one of the big reasons is you want your answer to look like my answer, look like your neighbor's answer. You don't want us all looking different, and then we're going to spend a bunch of time trying to figure out who's got the same answers. And they might be the same, but they just look so different that they're hard to tell right off the bat. So that's a really short answer, reason why I want you to do that. Okay. So let's try to use this. Okay, so a couple little notes here. Anything raised to a negative power on top flips to the bottom. And becomes positive. Ooh, that's not a P. So 1 over negative x, or x to the negative 1. Sorry, not negative x. On top. That was this one, sorry. It's backwards. X to the negative 1. And I say on top because it's over 1, whether you see it or not. Flips to the bottom. And becomes a positive. Anything raised to the negative power on bottom flips to top. And becomes... Now, when I say positive, I don't mean a positive number, I mean a positive exponent. So a negative number, 1 over negative 2, that's negative 1/2. That does not flip up to the top, it's not going to be 2. But 1 over 2 to the negative 1, that is 2. So you got to be careful that people start confusing negative numbers with negative powers. Alright, so what do we got? Now, one of the things people have a lot of trouble with is just their negatives. So negative 2 minus a negative 3. I get a lot of people telling me 1s or negative 1s. And it said negative 2. 2 minus negative 3. If you write down 2 minus a negative 3, you are 99% of the time going to give me 5. Okay? But if you do it in your head, you're going to get it wrong half the time. Or maybe not, I hope not. But a lot of my students get this wrong when they try to do it in their head. If they write down the operation, they get it right. Now we're going to simplify the same thing using the negative exponent rule. So that means anything that's got a negative exponent, we're going to flip. So this becomes x squared times x to the positive 3, now over 1, which ends up being x to the 5th. Very few people are going to get wrong addition, but they might get wrong minusing a negative. So how is process in A different than the process in B? They're not different, really. They're more different mindsets. If you're looking for an answer to put on this, you can say no difference. But A uses subtraction, whereas B ends up using addition. So that might be the helpful part for you. I mean, this is still addition. We're still doing 2 plus 3. But people have a less chance of getting things wrong in the second version. So the first version doesn't require any rewriting, so it's less work. The second version requires rewriting, but you're adding instead of subtracting. Okay, let's try a couple more real quick here. So remember, if you write this down, you're not going to get it wrong. So here's a couple things. This becomes p to the negative 11th. We can't leave it that way, so we're going to have to rewrite this as 1 over p to the 11th. Now let me let you in on a little hint here. When I do these, I think of them as subtraction. No matter what, division, subtraction. So if I'm subtracting a negative 8 from up the number line, so here's 0, here's negative 8, and positive 3. Subtraction is how far apart are these numbers? Are they 5 apart? No. 5 is this distance right here. They're not 5 apart. So the two numbers people give me from this is positive or negative 5 or positive or negative 11. I mean, that's the only two numbers we really get from these unless you're just adding them. So since we've decided that this is bigger than 5, it's got to be 11. The other question is where these 11 p's belong. So the other thing is, you got to realize which one's bigger. Is negative 8 bigger, or is positive 3 bigger? Positive 3 is bigger. There are more p's on the bottom, so those 11 p's end up being on the bottom. Alright, we're going to run out of time on this video. There is going to have to be a part 3, I guess. So I'm going to